Okay. So today we are going to see the topic searching. So searching is to find whether a particular value is present in the list or not. Because for the given element, for the given array, we are going to find the element is present or not. Okay, it can be element, can be a record or anything else, value, whatever be the case. Two popular methods for searching the array element are linear search and binary search. So these are the popular methods actually used. So there are other types of searching techniques also. So these two are very popular one, very much popular. We have jump search, then interpolation search. So in our syllabus, we are going to see four types of searching. The first two we are going to see the linear search and binary search. The algorithm that should be used depends entirely on how the values are organized in the array. So each and every searching technique will have its own algorithm. Okay, so this algorithm may varies. The efficiency may vary depends upon the how the values or the elements organized in the array. For example, how it is organized. For example, the array can be in sorted fashion also. Either it can be ascending order or it can be mm, descending order. So this is what the organization of the array. Okay, it may be fully sorted earlier, or it not may be sorted. Our uh, task is to find the given element is there or not. That's all. So the given elements in the array can be in sorted order also. Okay. If the elements of the array are arranged in ascending order, then binary search is used. If it is so, like if it is binary search, if it is like the elements are in ascending order or in descending order, so which searching technique is better when compared to others is that the binary search technique. So binary search technique can be used efficiently to search an element if the elements in the given array is in sorted fashion. Okay, so linear search. So from the name itself, we can tell the elements are going to be searched in adjacently. Okay, the other name for linear search is sequential search. We call it as sequential search also. So actually, what in case of linear search, we'll compare the elements, the current element with the adjacent element. Okay, if it is not there, once I find once I find try to search an element, if it is not matching, then I will go for the next element, next the contiguous element, adjacent element. If it is not matching, then I will go to the next element. So this is what the linear. Okay, this is what we have seen, linear data structures, all those things. Okay, the linear search is nothing but the elements are going to be searched contiguously. That's all. So is most used to search an unordered. So it is used for unordered list. If it is, if the elements are not sorted, okay, in such case, the which is the most efficiently used searching technique is that linear search. Okay, if it is not sorted, if it is like random, the numbers are random. Okay, we can go for linear search. So this is a given array. This is a given array example. I'm going to search an element, example 9. I'm going to search an element 9. What will I perform according to the linear search? First it takes the 0th index. Okay, 0th index. So I will search up to n minus 1. Okay, so first I check the array of 0, a of 0, if it is matching or not. No, 9 is not matching with 10. Then I'll increment the index I. So I is 0 is increment to 1. Then I'll check a of 1, it is matching or not. No, it's not matching. So I'll keep on move my what index until I find the matching element. So it takes, so once I find what happened, the algorithm quits. Once the 9 is matched, the algorithm quits. In such case, if the element 9 is not there, for example, you are going to search element 11. So you'll keep on start searching from the 0th index until it reaches the last element in the array. If there is not element 11 is not there, it returns the negative value, that it returns some value, returns that the element is not found in the given array. So what is the time complexity of this linear search? The time complex is that order of n. So if you are having n elements in the array, if you are having n elements in the array, then you can say the time complexity of the linear search is order of n. Okay, this is the worst case. Always we will tell about the worst case of the uh, algorithm, right? That we know very well, worst case. Why? Because why here order of n? If it is like 10 elements in the given array and the matching element, it is at the last index or the 10th index. So it will find at the 10th iteration only, 10th iteration only it will find the um, particular element. So that's why it takes order of n. Okay, so we have seen order of n, order of log n. Okay, in case of order of log n, next we'll see the binary search. Binary search will take order of log n time to find an element in the array. Okay, fine. So when you will choose the linear search technique, if the elements are in unordered fashion. So this is the basic algorithm for the linear search. So initially we are setting position equal to -1. Okay, when it will change to position, I mean 1 means is that if you find an element. If you are not finding an element, then finally if position equal to -1, okay, you will say that value is not present. If the -1 is not changed, if the -1 is not changed, it means that we are not found the value. It's meaning like that. So this is a step we are going to iterate the array. That's all. Simple for loop. You can use either for loop or while loop. Okay, you are going to iterate the what index. You are going to increment the index from 0 to n minus 1. So initially I'm setting index I equal to 1. Okay, instead of 0 we are setting that I equal to 1. You can set as 0, I equal to 0 also. Okay, here in this algorithm they set as what, 1. So I will start from I1 1 to n. Okay, suppose you are having 10 elements, so 1 to 10 elements I will set. If you are starting from 0, then I equal to will not be there. So 0 lesser than n minus n 10. If your I is 0, you can say that 0 lesser than 10. So nothing is there. Very simple. Then what you are doing? So this is the element you are going to find value. For example, 9. In our case, you are going to find 9. So that 9 is stored into the, I mean, checked. Actually, this is equal to equal to. Okay, you are checking is whether it is equal to or not. Okay, if it is equal, then you will what? You will terminate the while loop. If it is not equal, then you will keep on incrementing the I value, I mean the index value, until you find the exact match. So this is a very simple algorithm, nothing but you are going to use the for loop alone. For loop or any while loop you can use it, no issues. Then next we will move on to the binary search. So we have seen binary search, binary tree, and you know that binary tree consists of a parent consists of two child elements. And binary search tree, you know that the same technique we are going to follow in the binary search also. Binary search tree is that what, the root element, the left tree of the root element will always be lesser element. The same condition, same logic is followed here. Okay, so binary search is a searching algorithm that works efficiently with the sorted list. So already if it's sorted, okay, then we can go for binary search technique. If it is like sorted fashion, then we can go, they can choose the binary search technique. So what is the logic in searching? What is the technique? So we are going to find the middle index in the given array. So what is our logic? We are going to find the middle index. Okay, for example, we are going to like 10 elements in the array. Okay, we'll find the middle index in the given array. Okay, what is the, so middle index nothing but, what is the formula? Low index. Low index is nothing but 0. Low is nothing but 0. Suppose we are having 10 elements, 10 elements in an array. So what is the uh, 0, low index 0? Okay, it's because it starts from 0. Then plus high index is what, 9. It's because 0 to n minus 1, 9. Okay, divided by 2. So what is the answer? 9 divided by 2, it is 4.5. We will take 4. So the index 4 is the middle index. Okay, then we will compare with the what, whether the index 4 value is equal to the searching element or not. Okay, that we'll see next slide we'll see. So this is the binary search time complexity. What is the time complexity required by the or used by the binary search algorithm. So in each iteration or in each recursive call, okay, we can use either what recursive fashion or iteration manner. Either you can use for loop or keep on calling the same function that you know about recursive. That is what recursive call. Two types of function we can implement. Either it can be recursive call or iteration method. Okay, the search gets reduced to half of the array. Yes. Okay, so either we are going to traverse towards the left side or traverse towards the right side. Either of the end only we are going to start, either towards the extreme left or towards the extreme right. Okay, so by this what happens, or ultimately we are reducing the size of the array into half. The searching space is reduced to half of the elements in the array. Okay, that we have seen the binary search tree also. We have seen explained clearly in the binary search tree. The same thing is followed here. So for n elements in the array, so what is the time complex for a given n elements? Okay, so the time complex is log n, order of log n. So order of n to the base 2, log n to the base 2. So in case of linear search, the time complex is order of n, whereas in case of binary search, the time complex is order of log n. Okay, fine. We'll go for the example. So this is a technique. Okay, if value is not equal, very first I have found the middle element. Okay, I have found the middle element. As in our case we told that middle index is 4. Okay, a of 4, I'm going to search 10, for example. Element will take 15. I'm going to search an element 15 in the given array. Okay, the first step, what will I do? I will calculate the middle index. Now I found that it is 4. Okay, I have 10 elements in the array. So a of 4 is equal to the 15 or not. Array of 4 is equal to 15 or not. Okay, so here if it is not equal, if it is equal, I'll directly tell that the element is found. That's all, simple. The algorithm finishes. Okay, it exits the loop. If it is not matching, then you have to traverse toward the left side or traverse toward the right side of the array. Then what we have to do, then the values of the beginning, end and middle will be changed. If it is not matching, initially what is the beginning value? It is 0, nothing but low index. End is what? The high index, 9. Okay, we told that we have 10 elements. The low index is that nothing but beginning, it is 0. High index nothing but end, that is nothing but 9 in our case, in our example. And middle is 4. Okay, initially then if it is not matching, then we have to change the beginning, end and middle value. Again we have to change the beginning, end and middle. Based on the formula we'll change it. Okay, again we will check it. If it is not, for example, if it is not matching, then what we will check? If value 15 is lesser than a of middle, then if we'll go to the left side of the array. Okay, we have seen very clearly. Then val will be present in the left segment. Then we conclude that 15 is lesser than the middle element of the array. We will conclude that we have to go towards the left side only. That's all. Okay, so that is what this point representing. A point representing. What is the B point representing? If the searching element is greater than the middle element, we have to move towards the right end. Yeah, after finding whether to move to the left or right, then again we have to recalculate the values of beginning, end and middle value. So finally, if at all, if there is no value at all, if value is not present in the array, then what we'll say? End will be lesser than beginning. We'll say that what? The given element, the searching element is not in the array. When this happens, the algorithm will terminate and the search will be unsuccessful. Okay, because it cannot able to find the element. Why? Because the element is not in the array. Okay, we'll take an example for binary search. So this is the given element. So we told that the binary search will work on the sorted array. That we have to keep in mind. So here this elements are uniformly distributed here. Okay, for our example taken, but it can be like 22, 22, then 45, okay, 45, 63. So it will be like what, in sorted fashion. Okay, so now we are going to find an element 9. Okay, so we have taken from 0 to 10. Okay, now we will check with this. What is beginning now? Beginning is beginning nothing but index, zeroth index. This is index 0. When you take the same index also, it's same only. So index, I am writing the index value. Okay, this is the index value and this is the actual value in the given array. Both are equal only, so don't get confused. Okay, so it's keep on. So 6, 7, 8, 9, 10. So it means that we have 11 elements in the array, right? 11 elements in the array, and we are going to find the value 9. Okay, so initially what we told, we have to set the value of beginning, end and middle. So if beginning is 0, end is 10. So this is a 10, index 10. Okay, we are taking the index, that's all. Middle, lowest index plus highest index, 0 plus 10, 10 divided by 2 is 5. So now the middle is 5. Okay, I found that middle index is 5. According to the index, this is the decision point. This is the decision point where I have to move towards the left or right side. That's all. So a of 5, a of 5 is 5. A of 5 is nothing but what? 5. The value is 5. A of index 5, nothing but the value is 5. If it is less than value 5, lesser than what, 9, what happens? So we should not move towards the left side. So we should not move towards the left side. We have to move towards the right side, right? We have to move towards the right side. So I will ignore the first half of the array. This is how the time complexity is reduced in case of what? Time is reduced in case of a binary search. So we are very first step, we are reduce the half size of the elements, half of the elements. Now what I told, we have to change the beginning end value. Now how will you change the beginning? This is the formula: mid plus 1. What is a previously, what is the mid value? 5, right? So 5 plus 1 is what? 6. Now I have to check this elements only. Okay, priorly initially this is the middle value. Okay, index is 5, value and index are same. Okay, don't get confused. Again I am repeating. Okay, the middle index is 5. Okay, what is the new beginning value? Mid plus, so 5 plus 1 is 6. So now the beginning index, beginning values right now it is 6, and end no need to change. End no need to change, as it is. End is 10 only. Okay, why? Because we are going to search this whole elements. Okay, now again I have to calculate the middle element for this array. What is the, we told, lowest index of what is the index of this lowest index? 6, right? It is 6. You should not consider that this is a new array and you should not start from 0, 1, 2. It's not like that. Okay, actually it is wrong. What is the actual index of the element? 6. The actual index is what? 6. This is the lowest element and this is the highest element, 10. Again divided by 2. So it is 8. Now the 8 is the middle index. Now 8 is the middle index of this sub array of the right half. Then what will I do? I'll check with 8. I will check with the 8 with the 9. Compare the 8 with the 9. So it's not matching. So 8 is lesser. Then we conclude that we have to move towards the right side. We conclude that we have to move towards the right side. So what happens? So 8 is not matching. I conclude they have to move towards the right side. So I will take this half. So I will ignore now these elements. 6, 7, 8 is the middle point. I will ignore I'll ignore half of the elements from the subarray, right subarray. Okay. So now I move to this side. Again, I will calculate the beginning, end, and middle value. So what is the beginning value? Again, mid. What is the beginning is mid plus 1. So middle value is what? 8. Initially it was at the current stage it is what? 8. Then 8 plus 1, 9. Okay. Now the beginning is 9. For this I am going to search element from this array only. From this array only. I have reduced from 10, 11 elements to 2 elements now. Okay, this is how the binary search differ from the linear array. It will search all the elements in the array, but here it is reduced. I have done only 3 passes now. I have run the algorithm only for 3 times. Right now I have run for only 3 times. The iteration has been done for 3 times. Okay, and end is same. End will not change, right? End will not change. Then again 9 divided by 2, it is 18. So 9. So now the middle value is 9. I calculate the 9. Then I will match with the 9. I will match with this value to the searching value. Okay, now it is now it matches. So now I will return the index as well as the index that the match is found. This is how the binary search works. We'll think in this way, vice versa. For example, you're going to find an element 4. For example, you're going to find an element 4. What happens? Initially, this is the middle index. We told no. But very first, what we'll do? We'll call middle index. Okay. If it is lesser, 4 is lesser, then I will ignore this part. I'll ignore this part. I'll move towards the left side. Right? I'll move towards the left side. Now I have to change the value of beginning, middle, end. Okay. In this case, I won't change the beginning because beginning is 0. Beginning 0. I will change only the end value. I will change only the, now I will change the end value. End value is nothing but mid minus 1. Here we wrote what? Plus, right? Instead of plus, I will write minus. Why? Because I am moving towards the left side. If I am moving towards the left side, I will, this will be what? End. This will be end, right? This is end. What is the logic if I am moving towards the left? Beginning is as it is 0 only. Why? Because it is starting index is 0. I am moving to, and end only changes. End because it I have to search this towards this left off. So m minus middle minus 1 is nothing but the end. So I will search in this elements only. Again I will calculate the middle value. 0 plus what? 0 plus 0, 1, 2, 3, 4. 0 plus 4 divided by 2. 4 divided by 2, it's 2. Now the middle value is 2. I mean the index. I am telling about the index. The index is 2 for this left subarray. And again I will keep on what? If it is like, now it is matching. Now it's not. We have called for to search an element 4, right? We'll search an element 4. What happens? Now we have to move towards the right part. Now we have to move towards the right part. Now the end what? End won't change. We have to change the beginning. Now we have to change the beginning value. How will the beginning value? Middle plus 1. End is as it is. End is 4 only. It won't be changed. Now the beginning will be changed. Why? Because beginning should be 3 now. Okay, beginning should be 3. That's what I told. Beginning will be mid plus 1. This is how the searching works. Binary search works. Okay, so it's busy. The same I told about the algorithm. So we are calculating the middle value. Okay, position is mid. So we will check for the middle. Okay, and if it is like greater than, if the middle value is greater. Okay, what is middle value is greater? Nothing but we have to move towards the left part. That's why we are changing that mid minus 1. If you are moving towards the right part, what you will do? Mid plus 1. So you're moving toward the right side, mid plus 1. If you're moving to the left side, it is mid minus 1. Okay. Here it is returning, if it is like position is again same as minus 1, if it's meaning that there's no element in the array. Your search element is not there in the array. Guys, this is okay? Binary search is okay? Fine. Understood? Please reply in the chat window so that we will close the class. We'll complete with this class with the two algorithm. Is it okay? It's very easy only.